I just love doing my welding. The moment I pick up the torch, I come alive. I'm just someone who can endure hardship and never gives up. I always want to do everything well, to the extreme. As long as I can move, I'll keep working.
This is Aiguo, a member of the Communist Party of China and a master welder renowned for his exceptional craftsmanship and dedication. For over 50 years, he has overcome hundreds of technical challenges and served major national projects, advancing China's manufacturing industry. In this edition of our program, we bring you the story of Aiguo, China's master welder. At the heavy plate mill of Xiangtan Iron and Steel Group in central China, Aiguo and several workers are studying the welding of a critical structural component on a large imported electric motor.
The reinforcing brackets must be welded solid and secure. If the welds aren't secure, cracks can easily develop, and then the motor could explode. To be honest, I simply love welding. My wife once described me like this. After work, I'd come home and just lie on the bed, listless and limp like a sick chicken. But the moment there is a welding challenge to tackle or an emergency repair job out there, I'll spring right up as if possessed.
So, why is he so obsessed with welding? And how did he work his way up step by step from an ordinary welder to become a master in China's welding industry? Born in 1950 in central China's Hunan province, Aiguo entered the then Xiangtan Iron and Steel plant in 1969, working as a pipe fitter installing pipelines. At the time, there were welding technicians from Beijing on an aid mission at the plant. Back then, welding was a highly enviable skilled trade. Only 19 years old, he could only watch stealthily from the side while the welders worked.
I felt the craft of welding was beyond reach for me. I wanted to learn, but didn't dare speak up. But I noticed one thing: the oxygen cylinders they used for welding. The tall ones stood over 2 meters high and weighed about 95 kilograms, and even the lighter ones were about 80 kilograms. They had to lug them around every day. It was back-breaking work. And there were also those acetylene generators that needed to be loaded with carbide and filled with water. So, on top of doing my own job, I started doing all these things for them every day. One of the welders was impressed by me. One day he asked me, "Don't tell me you're interested in welding too." I said, "I'm sure I am. I'd love to learn from you."
By running errands for the welders and lugging their equipment, Aiguo's hard work won them over and opened a brand new door in his life. The welders from Beijing faced a heavy workload and decided to reassign 6 people from among the original pipe fitters to train as welders.
I've always believed that opportunity comes to those who are prepared. Whether I got it or not, I felt my efforts were not wasted. At the very least, I'd made a good impression as someone hard-working. I never even dreamed of it. They added 6 welder apprentices, and I officially became one of them.
Right after becoming a welding apprentice, he set himself a goal: becoming the best welder in his plant.
I have a habit of taking notes. I've always believed the dullest pencil is better than the sharpest memory. No matter how good your memory is, errors can creep in sometimes. I have a notebook which has been with me for over 50 years. My father gave it to me when I joined Xiangtan Iron and Steel Plant back in 1969. That's when I wrote in it, "Study and research diligently, overcome the tough challenges, and scale the heights of technical excellence." At the time, I thought to myself, I'm going to work towards becoming a grade 8 worker, the highest in my trade. My mentor back then was a grade 5. I wanted to surpass him.
Aiguo recalled that at the time there was only one grade 8 worker in the entire plant. In many people's eyes, a grade 8 worker was a living legend. He understood clearly that if he wanted to reach grade 8, he had to put in more practice and more hard work on his skills. He couldn't just scratch the surface. He had to become outstanding to reach the pinnacle of the craft.
Every day I would practice late into the night. I got burned a lot. Sparks and molten metal landing on the skin, that's routine. But I never once gave up, because I wanted so eagerly to master this craft.
A good welder needs more than just skilled hands. He can't be short on theoretical knowledge either. From his earliest days as an apprentice, whenever he had a spare moment, Aiguo would show up at the library, notebook in hand. Common welding materials, process parameters, basic procedures. All these fundamental aspects of welding knowledge were copied down by Aiguo in his notebook and committed firmly to memory.
My mentor and I shared a room. We lived together. He tried his best to teach me everything he could. Sometimes I practiced until 10 at night before heading back. Other times, when I really got into it, I'd keep going until midnight. Just like that, I was able to work independently within half a year.
Diligent in practice, thorough in learning, Aiguo's skills grew ever more proficient day by day, and he began to take on major welding challenges in his plant.
In 1975, the coking workshop at our plant needed to run ammonia, sulfuric acid, and the like through its pipelines, so copper pipes had to be used. When I heard about this, I went straight to the library to look up information on copper welding.
Before this, Aiguo had primarily welded steel. Compared to steel, copper is prone to oxidation, distortion, and porosity during the welding process, all of which make it much more difficult to weld.
I started with a small welding torch. As I welded, things started to make a little more sense. The next day, I used a medium-sized torch. This torch had 5 nozzle sizes, and the number 5 was the biggest. In the end, with the number 5 nozzle, the whole process went much more smoothly.
Through repeated trial and error, Aiguo discovered that copper becomes highly fluid once melted, so the filler rod couldn't be too fluid either. Otherwise, the molten metal would drip downwards, resulting in uneven welds and poor formation. Finding the right filler rod then became the next challenge he had to tackle. After more than half a month of continuous experimentation, he finally found the perfect match.
Of course, I'm making it sound simple now, but it actually took many days, swapping filler rods back and forth. Some rods we didn't have in stock, so I went out looking for them elsewhere. In the end, I welded over 200 meters of copper pipe in one go. Pipes ranging from 51 millimeters in diameter to 108 millimeters. The larger the pipe diameter, the harder it is to weld. I never expected it would turn out so successful. That gave me a real sense of achievement, and it also gave me the confidence to tackle future welding challenges.
From that point on, Aiguo dedicated himself even more to acquiring welding knowledge and honing his welding techniques. In 1982, he passed the examinations for both gas welding and electric welding certificates with outstanding results, becoming the only welder in his workplace at the time to hold both certificates. In the face of these achievements, Aiguo didn't grow conceited or complacent. Instead, he pressed on to take on even greater challenges. Back then, the blast furnace tuyères used in steelmaking to inject oxygen and fuel into the furnaces suffered severe burn-through damage, with a typical tuyère lasting only 1 or 2 months. If a new channel-type tuyère made of copper could be adopted, its service life could be extended to 6 months or even a year. But copper conducts heat extremely quickly. During welding, the heat dissipates so rapidly that it becomes difficult for the base metal and the filler material to fuse together properly. Welding was crucial for the success of this new approach. In 1983, the then Ministry of Metallurgical Industry launched a nationwide initiative to tackle the tuyère welding problem. Upon hearing the news, Aiguo volunteered to take part and advocated for an innovative approach, using argon arc welding, a technique that was not yet widely adopted at the time.
Argon arc welding means the arc is surrounded by a shield of argon gas. The workpiece is heated by the electrode, and with the argon shielding in place, it's isolated from the air, making the weld far less prone to porosity. That's argon arc welding.
The new type of tuyère was made of copper and weighed over 100 kilograms, being a large workpiece in welding terms. The welding difficulty was immense.
The copper tuyère is too large, which makes it difficult to heat. And when heating was difficult, the heat dissipation becomes uneven. If it's uneven, cracks can easily develop, and the weld won't form properly.
Aiguo and his teammates worked through the problem by conducting experiments. He discovered that because copper dissipates heat so quickly, the new type tuyère had to be continuously heated during welding. This meant the ambient temperature around the tuyère became extremely high during the welding process. As a result, the welder had to wear extra protective gear.
The asbestos blanket can withstand temperatures of over 1,500 degrees Celsius. I covered myself with it to insulate my body, so the heat wasn't quite so unbearable. The welding torch itself would heat up to over 100 or even 200 degrees, so it had to be completely wrapped in heat-insulating cloth. And my gloves had an asbestos inner layer with leather on the outside. That helped keep my hands from getting injured.
Even with these precautions, some of the heat still penetrated through the asbestos blanket and gloves, searing the welder's skin.
Blisters formed on my hands every time I finished welding. That's how grueling it was. But I always just wanted to get the job done well. So when the blisters came, I'd prick them with a needle, apply some medicine, and a few days later, I'd be back welding again.
After running over 100 tests on used tuyères, one day in January 1984, Aiguo felt the moment had come.
So I was full of confidence. I thought, during the experiments, the welds had all been successful. Surely this time would be no different. Our workplace canteen had even prepared a celebration dinner. The plan was that once the tuyère was successfully welded, we'd send news of the triumph straight to the Ministry of Metallurgical Industry. But when I started welding, and no matter what I did, the fusion just wouldn't work properly. The molten pool wouldn't flow smoothly. It was either porosity or cracks. By the time it was past 1 in the afternoon, there was no hope, but I was still at it. An older colleague standing by said, "Give it up, lad. This job isn't meant for the likes of us."
Aiguo suffered the first Waterloo defeat of his welding career.
I didn't attend the celebration dinner. I just went straight back home. I took a shower and went to bed. But with something weighing so heavily on my mind, I couldn't fall asleep. I just kept tossing and turning, wondering why it hadn't worked. It wasn't just embarrassing, it was utterly humiliating.
The unexpected setback didn't stop him from pressing forward. He regrouped, carried out repeated analysis and verification, and finally found the cause of the failure. It turned out the old and new tuyers differed in both structure and weight. The used tuyer they tested on weighed only around 100 kilograms, while the new tuyer to be formally welded weighed over 150 kilograms. On top of that, welding took place in winter, so heat dissipated even faster. These differences together led to the welding failure. Having pinpointed the problem, Aiguo adjusted his welding plan and, together with the electrical engineer in charge of regulating the current, once again rose to the challenge. Finally, in March 1984, he made it.
Once I got up there, I saw the current was on, but I thought the temperature still wasn't high enough. Normally, we'd see around 600 odd degrees Celsius in the books. I told my colleague to adjust temperature to 700 degrees, then to 750, and finally to 850, and that did it. The entire welding was finished in a little over an hour. When the final inspection came in, the results showed the welding was a success. At that moment, I was elated. In my heart, I said, "It's finally done." After the success, our company decided to weld 20 copper tuyers. I ended up welding every single one of them, exactly enough for 2 blast furnaces.
For this achievement, he was awarded the second prize of the National Science and Technology Progress Award in 1987. This breakthrough also made his name in the metallurgical industry. By then, Aiguo had already achieved both fame and success, and many opportunities came his way to be promoted into a management position. He declined them all.
I told them I'm not cut out for management. I just love doing my welding. The moment I pick up the torch, I come alive.
Because of this passion, the pain and solitude of welding work all became a source of joy for him. In 1985, he was honored to join the CPC, the Communist Party of China. For him, he says that a good CPC member must possess real skill and competence. He lives by the principle of never being too old to learn. Not only has he himself persisted and pushed forward with determination his whole life, but he is also strict with his apprentices. His apprentice, Ouyong, says that Aiguo has passed down the craftsmanship of meticulousness and the relentless pursuit of excellence.
He always says there's absolutely no room for cutting corners in welding. Many quality problems in metal structures stem from poor welding. If you try to fool it, it will fool you right back. What he says most often is, in welding there are no small matters. Not a bit of error is acceptable. Even a tiny fraction off just won't do.
Over the past 50-plus years, he has trained more than 600 welding technicians. Throughout his career, he has overcome more than 400 welding technical challenges and improved over 100 welding processes. Thanks to his outstanding welding expertise and experience, Aiguo was rehired after his retirement in 2015 as a welding consultant for Xiangtan Iron and Steel Group. In that position, he continues contributing his wisdom and dedication to new challenges in China's welding field. In March 2021, a steel pipe company in northern China's Hebei province ran into a difficult problem. A crack had appeared in an expanding shaft measuring 0.3 meters in diameter and 18 meters in length. To get this expanding shaft back into working condition, the most economical and feasible solution was repair by welding. When the steel pipe company sought out Aiguo, he understood full well just how difficult this would be.
Inside this expanding shaft is a drawbar. Welders generally don't dare touch shafts. Why don't they dare? First, it's not easy to carry out heat treatment on a shaft. Second, whenever you weld, the process will produce distortion, and it's extremely difficult to guarantee its concentricity and strictness.
This was a super-scale challenge no one dared to take on. But Aiguo, already 71 years old at the time, accepted it.
After taking on this task, because the shaft had a crack, we needed to cut away the cracked section. Around a meter and a bit had to be removed. The first step was to find out whether there was any facility in our country capable of cutting off this section of the shaft, because we then need to replace that section. The second question was whether there existed a welding wire strong enough to match the original strength of the shaft. In the end, I put together a fairly complete welding procedure. I drew up the blueprints and finally took them to the company in Hebei province. The company assembled a panel of more than 10 engineering and technical experts, and they asked me questions. In the end, my solutions won their approval.
One day in July 2021, all the welding preparations were in place, and the welding of the expanding shaft officially began. Aiguo directed 2 welders to work together, following the welding procedure they had mapped out in advance. However, once the preheating was complete and the welding got underway, Aiguo spotted a problem.
While they were welding, I was observing the molten pool of each weld seam at all times. I noticed the molten pool wasn't flowing quite smoothly. It looked a little unclean. The molten pool is what forms when the filler wire and the base metal melt and fuse together, like a small bowl of liquid. If this molten pool isn't clear and bright, it means the filler wire and the base metal aren't fusing together very well.
To get the molten pool to flow more smoothly, the voltage needed to be increased. But if the voltage was raised too high, the molten pool would enlarge correspondingly, which would lead to a welding failure. So, exactly how high should the voltage be set? Aiguo didn't have absolute certainty. He could only rely on his years of experience, keeping a close eye on the instrument readings and every subtle change in the molten pool, until he finally found the right voltage.
So I adjusted the voltage. It was originally 30 volts, and I raised it to 32 volts. Once the voltage went up a little, the molten pool became clearer. That improved the fusion between the filler wire and the base metal, and the weld quality became less prone to defects.
In the end, after more than 10 hours of continuous, intense work by Aiguo and the 2 welders, the expanding shaft was perfectly repaired. X-ray inspection showed a weld pass rate of 100%. Every indicator of the expanding shaft met the equipment's operational requirements. On June 29, 2021, the grand ceremony for conferring the July 1st medal, celebrating the 100th anniversary of the founding of the Communist Party of China, was held at the Great Hall of the People in Beijing. Chinese President Xi Jinping presented welder Aiguo with the medal, which is the highest honor in the CPC. The medal citation stated that Aiguo, a CPC member, is an outstanding exemplar of craftsmanship. He has dedicated over 50 years to his post as a welder, constantly striving for excellence and pursuing the extraordinary. Bold in innovation, he has overcome hundreds of technical challenges, becoming a master of unique skills and a pace setter in the welding industry. An old Chinese saying goes, "An old steed in the stable still yearns to gallop 1,000 miles." Now in his 70s, the master welder continues to work on the front lines of production and scientific research.
I'm just someone who can endure hardship and never gives up. I always want to do everything well, to the extreme. As long as I can move, I'll keep working. Right now, I'm studying laser welding and robotic welding, how to effectively combine my welding skills and experience with the capabilities of robots, to fully leverage the role of robotic arms, and to fully apply laser welding in practice, so as to further contribute my part to China's manufacturing industry.
With that, we conclude this edition of Footprints. Thanks for listening. I'm Bob Jones. If you're interested in hearing more about the lives of ordinary but incredible people in China, follow us on your favorite podcast platforms. Just key in Footprints and you can find more stories anytime, anywhere. We'll see you next time. Bye for now.